Welcome to Brain Vision.
So we have a pumpkin on a frictionless dome, and ultimately the goal is just to find when it loses contact with the surface, and that's going to happen when the normal force is 0. So if we can figure out when that happens, then we can determine the angle. So we have a normal force here. I'm just imagining this point is where it slips off. I don't know exactly where it is. That's what we're trying to find. So we have the normal force perpendicular to the surface, and then we have the weight, or the gravitational force opposite the weight. And then I'll call this point at a height h, and the initial height where it starts is just the radius of the dome. So we can set up, we're going to need two equations, one for the force and one for the energy. So for the force, we have the normal force, then minus, I'm going in the perpendicular direction now, so we want to find this force, which is the perpendicular component of the gravity, so that's mg cosine theta. And this theta we're looking for is this angle right here with the vertical. And this is going to equal ma, but we're falling down, so this is going to be minus ma. So this is n minus mg cosine theta. It's going to equal minus m times v squared over r. That's how we convert it when we're working with centripetal acceleration. And then we said we want the normal force to be 0. So we can just substitute that in. We get 0 minus mg cosine theta. And this is going to happen at our final velocity, vf. And then so we can get rid of some stuff. All this goes away. We get g cosine theta equals vf squared over r. So vf squared is gr cosine theta. Now for the energy, we can just simply do kinetic initial plus potential energy, and then the same thing for final. Now the initial kinetic energy is 0 because we're not moving. So we just have to worry about potential energy, which is going to be m times g times the height, which is r. The final kinetic energy is 1/2 m vf squared. And the final potential energy is mgh. Now h, so if this is this length here, right here, is h, and this is r, which means that h is going to be, we can use the sine of this angle, the interior angle there. So h is r times sine of that angle, but we want to use the exterior angle, theta. So h is really r times cosine of theta. Well, first we can cancel the masses, and we get gr equals 1/2 vf squared plus g, and h is r cosine theta. And then vf squared we have up here. So this is going to be 1/2 gr cosine theta plus gr cosine theta. So, well, the gr all cancels, so this is like 1. We can cancel them out because we know they're not 0, so I don't have to do any factoring. This is going to be 1/2 plus 1, so 3/2 cosine theta. So cosine theta equals 2/3. And if we take cosine inverse and take the positive solution, we get 48.2 degrees.